Net force is total force on an object. So you add all the forces together. Forward things are positive, backward things are negative. You can only do one direction at a time. We'll get there when we get to the practice. But so right now, total force on an object. Okay? Good. Let's see. Riley, do you all have 4? You had 4, right? What'd you get for mechanical equilibrium?
Net force on something is 0.
Bingo. Oh, we are cruising. There you go. Equilibrium is when the net force is 0. 0 newtons. Killing it. All right. Hayden, what about 5? Explain support / normal force and what it has to do with mechanical equilibrium.
I got them flipped, but
Fair enough.
support force, upward force, opposite of Earth's gravity.
Yep.
And then normal force is equal to the object and the upward force support.
Yeah, they basically are the same thing. Basically, they're the force that works against gravity trying to pull down. And how it relates to mechanical equilibrium is normal force generally makes things be in equilibrium. So support force and normal force is basically force against gravity. Now be careful, because that may make some parts later on confusing. But support force or normal force is basically a force that works upwards against gravity pulling down. It doesn't have to be up, by the way. There's a bonus problem on the practice, and the bonus problem, the normal force, is not up and down. What does it have to do with mechanical equilibrium? That normal force plus negative gravity, because gravity's down, gives you a net force of 0. So the reason why it has to do with equilibrium is because they generally will balance each other out. Good. All right. Number 6. Vaughn, what about number 6? What you got for that one?
7.
Oh, you did 7? Okay. You guys did 7. Josh, you got that one? You got 6?
You have to apply force and something to accelerate.
Good. How are force and acceleration related? So they're directly proportional, which means if you increase one, you increase the other. And a good way I like to remember it is A equals 0 if F net equals 0. So here's a really quick minor thing. Just because there is a force does not mean the net force is 0. Okay? The forces don't have to balance out. Likewise, if there is force, that doesn't mean it accelerates. If the forces are balanced, then it won't accelerate. So don't assume it has to change. But it very well might. Okay. So, Vaughn, you said you had 7. Good. So, sliding friction or kinetic friction is motion friction. And what they have to do with acceleration is they slow the acceleration down, so they make it smaller. And I liked your explanation about because it uses energy. That's a good way to think about it. So it slows A down because it uses energy. Good. I like that. Look at us rip-roaring through this. Anyone have any questions for me so far on the front page? go. Rip roaring. All right. Number 8. Let's see. Martin, is that what you had? Do you have 8?
Yeah, I did.
Okay, what you got for 8? What's static friction? What's that have to do with equilibrium?
I said static friction. I said it takes more force to get an object moving than it does to keep moving.
Yeah. So static friction is stationary friction. It's the friction that keeps you from moving. So friction that keeps objects from moving forward. Okay. This is true only when net force is 0. If the net force is not 0, it'll be kinetic friction. Or if the net force is 0 and it's moving. So that also could be another case. But it's stationary friction. It prevents motions only when net force is 0. And he also mentioned that it's always larger than kinetic. So static friction is always going to be larger than kinetic friction. That's always true. All right, I didn't get anyone 9, so I'll look at 9 here. So differences between mass and weight. So mass is what an object has. Weight is the force of gravity on that mass. So mass is basically a measure of an object's stuff. There you go, super scientific word. Or you can think of it as like an inertia measurement. Weight is gravity's force on that mass. All right, it's important to note they are always related to each other by whatever the acceleration of gravity is, which means the weight, the force of gravity, is always about 10 times more than what the mass is. Okay? So if you have a mass of 10, your weight is about 100. Okay? It's not always exactly perfect, but that's pretty close on how the scale works. So that's the basic idea there. Good. All right, number 10. Let's go to the other side. Ethan, did you guys have 10 and 11?
We didn't, but I have the answer.
Oh, fair enough. All right, what do you got for number 10? So weight, force of gravity, and normal force are usually equal, but they're not always. Why do you think this is? Okay, why do you think?
It's equal when the normal force keeps us from tipping down,
Mm-hmm.
and what's the other one called?
Equilibrium?
Force of gravity.
Yep.
From flying away, but when you have an object that's moving, say like something like an airplane,
Mm-hmm.
there would be a difference.
Good. All right. The force of gravity equals the normal force when the net force is 0. However, Fg does not equal the normal force when Fnet does not equal 0. All right, you've already probably had an experience where you've all probably been in an elevator at some point. Okay? If you've been in an elevator, you know that this is true. When you stand in an elevator, you're at rest. If you would like to go up, you have to accelerate. When you accelerate up, the force is no longer a net force of 0. There has to be a net force up. Okay, stay off the solitaire, please. Didn't get it fast enough that time. All right, so anyway, just keep in mind that the net force is 0 only if you're not changing your motion. So when you accelerate upwards on the elevator, you feel heavier. And the reason you feel heavier is because normal force is larger than gravity. When you get to the top of the elevator, when you get to your destination, you feel lighter because gravity is larger than normal to slow you down. Okay? So usually those things are equal because normally the net force on you is zero. Right now you don't feel like you're accelerating because the net force on you is zero. Okay? If all of a sudden a sinkhole opened up, okay, then you would all fall down and you would not feel like you were at rest, and you would feel the force of gravity pulling you down. So the net force would not be zero, and therefore gravity and normal force would not equal. So why are they equal usually? Because the net force is usually zero. If the net force is zero, you're going to run into an example where they're not. Ashley, can you put the phone away? Thanks. All right, so that's kind of an example to think about with that. So when the net force is zero, they're equal. When the net force is zero, they're not equal. And I'm talking about vertical net force. You could have a horizontal net force. That's not zero. Basically, when gravity and normal don't balance out with each other. Good. Number 11. Let's see. Scott, do you have number 11? Nope. Let's see. Who's got 11? Franchette, you got 11? Ben. You got John's got it again. All right. You got for 11. Good. So they're inverse proportion. Ooh, good question. Yep. They're inversely proportional, which is more mass, the more inertia, so it's harder to get. All right, so you asked a good question. Was if you have a heavier object, it accelerates down a hill faster. The reason is when you have a heavier object, so if you have a big rock versus a little rock, it's just mass. The force pulling down is actually larger. So not only is there an inverse proportionality between mass and weight, but there's also a direct proportionality between force and acceleration. So the force will end up being larger change than the mass will. That's why you end up having. One of my favorite song lyrics of all time is there's a song that none of you've heard before. It says something about like don't feel bad for the skinny person because the world a fat person and a skinny person on a mountain. The person anyway. It's a ridiculous song. None of you have, I guarantee you have heard before. But that's because I listened to way too many songs in my life. All right. Excellent job. 12. All right, let's see. Franchette, you got 12? All right, what do you got for 12? What is Newton's second law? Yep, that's fine. What you got? Good. I like it. Squiggly thing. Yep. I think it's called tilde, but I don't actually know that. Squiggly sign. Oh, so the squiggly shows it's proportional. To be fair, really is equal. I don't know why they do it that way. But this equation, you may be more familiar with this one. F net equals ma. Or maybe even this. I'll write for you. This shows me that more force means more acceleration, and more mass means less acceleration because they're opposites of each other.